fluid. So what is fluid? Any substance which is capable of flowing and has no fixed shape. For example, liquids like water, oil, honey, paint, blood, gases like carbon dioxide, hydrogen, nitrogen, including water vapors. Next comes the types of fluids. Fluids are of following types like ideal fluids, real fluids, Newtonian fluids, non-Newtonian fluids, incompressible fluids, and compressible fluids. So we will study them one by one. First come ideal fluids. So what are ideal fluids? The fluids which are incompressible and have no viscosity and surface tension are called ideal fluids. These are only imaginary fluids and do not exist in nature. तो ideal fluids क्या होते हैं? The fluids जिनके पास कोई प्रॉपर्टी नहीं है, जैसे कि इनकम्प्रेसिबल होते हैं, ये विस्कोसिटी नहीं है इनके पास, सरफेस टेंशन नहीं है इनके पास. So they have no viscosity, no surface tension, and are incompressible, not compressible. Next come real fluids. The fluids which possess properties such as viscosity, surface tension, and compressibility are called real fluids. अब real fluids क्या होते हैं? Real fluids वो fluids होते हैं जिनके पास ये सब properties होती है, जैसे कि viscosity, surface tension, and compressibility. Next are Newtonian fluids. Newtonian fluids are the fluids which obey Newton's law of viscosity. Newton's law of viscosity means that shear stress is directly proportional to the rate of shear strain. तो जिनमें Newton's law of viscosity को जो fluids obey करते हैं, that are called Newtonian fluids. Next are non-Newtonian fluids. Non-Newtonian fluids are the fluids which do not obey Newton's law of viscosity. That is, shear stress is not directly proportional to rate of shear strain. Next are incompressible fluids. What are incompressible fluids? When the density of fluids doesn't change with the application of external force. मतलब density का मतलब आप सबको पता होगा, density means mass per unit volume. जब किसी fluid की density change नहीं होती, when external force is applied on them, it is called incompressible fluid. वो compress नहीं होते हैं. Next are compressible fluids. When the density of the fluid changes with the application of external force, it is known as compressible fluid. जिनमें density change हो जाती है with the help of external force, वो fluids होते हैं compressible fluids. Now the next term is viscosity. What is viscosity? Viscosity is a measure of the thickness of a fluid, and it is the property of fluid by virtue of which it offers resistance to the movement of one layer of fluid over an adjacent layer. For example, we can take the case of water and honey. We know that water is thin liquid as compared to honey. So in case of water, viscosity is less as compared to honey. Honey has more viscosity. Next topic is types of fluid flow. So now there are 6 different types of fluid flow, like steady flow, unsteady flow, uniform and non-uniform flow, laminar and turbulent flow, compressible and incompressible flow, rotational and irrotational flow. Next are 1, 2, and 3-dimensional fluid flow. So we will study them one by one, starting from steady and unsteady fluid flow. Steady flow is defined as that type of flow in which fluid characteristics like velocity, density, pressure, etc. at a point do not change with time. That is, the fluid characteristics remains constant. So steady flow कौन सा flow है जिसमें जो fluid characteristics हैं जैसे कि velocity, density और pressure ये change नहीं होते हैं with respect to time. तो इनमें हम ये भी मैथमेटिकली लिख सकते हैं डेल्टा v by delta t is equal to 0. That means change of velocity with respect to time is 0. It is constant. Delta p by delta t is 0 means change of pressure with respect to time is 0. It remains constant. And delta rho by delta t is equal to 0 means density does not change with respect to time. Next are our unsteady flow. Unsteady flow is defined as the flow in which the fluid characteristics like velocity, density, pressure, etc. at a point changes with respect to time. अब unsteady flow कौन सा flow होता है जिसमें कि fluid की characteristics जैसे कि velocity, density and pressure ये change होते हैं with respect to time. These are not constant. So mathematically we can write delta v by delta t is not equal to 0. Means velocity with respect to time is changing. It is not constant. Next come our uniform and non-uniform flow. So first is uniform flow. The uniform flow is defined as a type of flow in which the velocity at any given time does not change with respect to space or distance. Means velocity is constant with respect to space. Velocity change नहीं होगी with respect to distance at any given interval of time. So mathematically we can write delta v by delta s at time is equal to constant is equal to 0. It means कि velocity change नहीं हो रही है with respect to space or distance. Next are our non-uniform flow. Non-uniform flow is defined as the type of flow in which the velocity at any given time changes with respect to time. Non-uniform flow जो होगा उसमें जो velocity होगी वो change करेगी with respect to space or distance. Next are our laminar and turbulent flow. Laminar flow अब क्या होता है? Laminar flow it is defined as the flow in which the fluid particles move along well-defined paths or streamlines and all the streamlines are straight and parallel. मीन्स इसमें जो फ्लूइड पार्टिकल्स होंगे वो सीधे सीधे मूव करेंगे, पैरेलल मूव करेंगे, एक दूसरे के लेयर्स को क्रॉस नहीं करेंगे. और टर्बुलेंट फ्लो कौन सा होगा? इट इज द टाइप ऑफ फ्लो इन विच द फ्लूइड पार्टिकल्स मूव इन अ zigzag वे. द एडिस फॉर्मेशन टेक प्लेस विच इज रिस्पॉन्सिबल फॉर हाई एनर्जी लॉस. तो इसमें टर्बुलेंट फ्लो में क्या होगा? जो फ्लूइड के पार्टिकल्स होंगे वो zigzag मोशन में ट्रेवल करेंगे, वो एक दूसरे की लेयर्स को क्रॉस करेंगे. This is the diagram. You can see here the laminar flow and turbulent flow. In laminar flow, the particles are moving straight. These are the particles of fluid. These are moving in straight. These are not crossing the path of other particles. And this is the case of turbulent flow, in which the fluid particles, you can see here, these are moving in a zigzag way and crossing the path of other particles. So in this figure, you can clearly understand the difference between a laminar flow in which the fluid particles are parallel and not crossing the path of other particles, and in this figure you can see the turbulent flow in which the fluid particles are moving in a zigzag manner. Next topic is rate of flow or discharge. This topic is very important. So what is discharge? The volume of liquid flowing across any section of pipe or a channel per unit time is called rate of flow or discharge. It is generally denoted by Q. Discharge क्या होता है? Discharge is defined as the volume of liquid flowing through any section of pipe per unit time. कितना क्वांटिटी ऑफ वाटर कितने टाइम में बाहर आ रहा है पाइप से या चैनल से, दैट इज कॉल्ड डिस्चार्ज. इट इज डिनोटेड बाय क्यू. एसआई यूनिट्स ऑफ डिस्चार्ज आर मीटर क्यूब पर सेकंड और वी कैन से लीटर्स पर सेकंड. एंड हियर इज द फॉर्मूला फॉर फाइंडिंग डिस्चार्ज. Discharge is denoted by Q. Its formula is A into V, where A is cross-sectional area of a pipe and V is mean velocity of flowing liquid. A is area and V is velocity. Next is continuity equation. Now what is continuity equation? Continuity equation is defined as the product of cross-sectional area of the pipe and the velocity of fluid at any given point along the pipe. And it is constant. Means the inflow is equal to outflow, or we can also say like discharge at entry is equal to discharge at exit. So mathematically we can write what is discharge? A into V. At inlet discharge is A1 into V1. At outlet the discharge is A2 into V2. So we can write A1 V1 is equal to A2 V2 because inflow is equal to outflow. The product of area and velocity at any given point along a pipe is constant. Here A1 is cross-sectional area of pipe at section 1, A2 is cross-sectional area of pipe at section 2. Similarly, V1 is velocity of flow at section 1 and V2 is velocity of flow at section 2. And the continuity equation is based on the principle of conservation of mass. Our next topic is types of hydraulic energies. Now, we know that there are three types of hydraulic energies. Water possesses three types of energies. First is potential energy or elevation energy. Second is kinetic energy or velocity energy. Third is pressure energy or flow energy. So starting from potential energy. Potential energy is the energy possessed by liquid body by virtue of its position above arbitrary datum. Means the energy possessed by liquid by virtue of its position or height. Then the energy is called potential energy. It is generally denoted by capital Z. Next is kinetic energy. We all know that energy possessed by liquid body by virtue of its motion or velocity. तो kinetic energy है वो होगी liquid body के motion और velocity के कारण. And it is denoted by v square upon 2g, where v is the velocity and g is acceleration due to gravity. Next is pressure head or pressure energy. The energy possessed by a liquid body by virtue of its existing pressure is called pressure energy. It is denoted by P upon rho g or P by W, small w. Now what is P? P is the pressure of a fluid and W is specific weight. Next is our Bernoulli's theorem. This equation is very important and often asked in government exams and whenever you appear for an interview. So you must know this Bernoulli's equation. So in 1738, a Swiss engineer Daniel Bernoulli gave a theorem for frictionless and incompressible liquids. So according to this theorem, what this theorem states? This theorem states that in an ideal and incompressible fluid, when the flow is steady and continuous, then the sum of all the hydraulic energies remain constant along a streamline. That is, now we all know in previous slide we have already studied the types of hydraulic energy. So what are the types of hydraulic energy? Potential energy, kinetic energy and pressure energy. So what this theorem is saying that the sum of all the hydraulic energies remain constant, means the sum of potential energy, kinetic energy and pressure energy is equal to constant. Or mathematically we can write the potential energy is denoted by Z plus kinetic energy is V square upon 2G plus pressure energy is P upon small w. It is constant. Next are the assumptions in Bernoulli's equation. So in deriving the Bernoulli's equation, there are some assumptions which are to be followed. The assumptions are, first is the fluid is ideal and incompressible. So I have already told you about the ideal fluid and incompressible fluid. The fluid is ideal and incompressible. Second is the fluid is steady and continuous. Third is velocity is uniform over the section. Next is flow is one-dimensional, that is along a streamline. And last is no external force acts on the liquid except the force of gravity and pressure. So all these assumptions are to be taken into consideration while deriving the Bernoulli's equation. So next is our applications of Bernoulli's theorem. Now this topic is very, very important. The applications of Bernoulli's theorem. So the following are the applications of Bernoulli's theorem. First is venturimeter, second is orifice plate meter, and third is PITOT tube. So we will study them in detail in next slides. So first comes venturimeter. Venturimeter is a device that is used to measure the rate of flow or discharge of fluid through a pipe. This device is based on the principle of Bernoulli's equation. तो वेंचुरीमीटर क्या है? वेंचुरीमीटर एक ऐसी डिवाइस है that is used for measuring the rate of flow or discharge of fluid through a pipe. And I have earlier told you about discharge and rate of flow. Discharge is the quantity of liquid coming out of a pipe or a channel per unit time, denoted by Q, and its units are meter cube per second. सो वेंचुरीमीटर एक ऐसी डिवाइस है जो कि डिस्चार्ज मेजर करने के काम आती है, और ये जो डिवाइस है दैट इज बेस्ड ऑन द प्रिंसिपल ऑफ Bernoulli's equation. So the main parts of a venturimeter are, it has three main parts. First is converging part, second is throat, and third is diverging part. So we can see it in the next figure. So this is the figure for venturimeter. This is a pipe having diameter D, cross-sectional area A. Now this is venturimeter consisting of three parts. We can see here, first is converging part, where the area of pipe is decreasing. It is gradually decreasing. This area is known as throat. This area is known as throat, where the area is constant and minimum. And third part, this one is diverging part, where the area is again increasing. So this is venturimeter consisting of three parts. I'm again telling you, the first is converging part, where the area is gradually decreasing. This is throat, where the area is constant and minimum. This is diverging part, where the area is increasing. And to find the pressure difference between the inlet and outlet. Inlet here is section 1 and section 2 is taken at throat, And for measuring the pressure difference between section 1 and section 2 means the inlet and outlet, we have placed here a U-tube differential manometer containing a heavy liquid like a mercury. So the difference in mercury level, this is denoted by H. This is denoted by H. And the actual discharge is given by, in case of venturimeter, it is given by Q is equal to CD into A1 A2 under root 2GH divided by under root of A1 square minus A2 square. The actual discharge is given by this formula. In case of venturimeter, here we can see the CD is coefficient of venturimeter and its value is always less than 1. CD is coefficient of venturimeter and its value is always less than 1. A1 is cross-sectional area of pipe at section 1. A2 is cross-sectional area of pipe at section 2. And G is acceleration due to gravity, and H, I have earlier told you in previous slide, look here. H is the difference of mercury level in U-tube differential manometer. This is H. So its formula comes out to be CD into A1 A2 under root 2GI divided by under root of A1 square minus A2 square. So next application of Bernoulli's theorem is orifice plate meter. Orifice plate meter after venturimeter. So what is orifice plate meter? Orifice meter is a device that is used to measure the discharge of fluid through a pipe with the help of U-tube differential manometer. तो ये भी एक ऐसी device है. Orifice meter is also a device that is used to measure the discharge of fluid through a pipe with the help of a U-tube differential manometer. इसमें भी हम discharge को calculate कर लेते हैं. Measurement of discharge. This device is used for the measurement of discharge, and it works on the same principle as that of venturimeter. Means Bernoulli's theorem. Now the orifice meter consists of a flat circular plate having a sharp edge circular orifice which is concentric with the pipe. You can see it in the next figure. Yes, this is the figure. This is a pipe of diameter D having cross-sectional area A. This is the direction of flow. This is orifice plate. This one in orange color is orifice plate. This is the opening known as orifice. So this is the diameter. We can see here in the slide that from here to here, this is the DO is the orifice diameter of orifice. Here is section 1. At orifice we have taken section 2. This is inlet, this is outlet. So for measuring the pressure difference at section 1 and section 2 means the inlet and outlet, again we are using U-tube differential manometer. We are using U-tube differential manometer having a heavy liquid like a mercury, and the difference of mercury level here, it is denoted by H. So again it is denoted by H. And this is vena contracta. Vena contracta means the area of jet where the section is minimum. This one, we can see here that at this point the area is minimum. So the point where area is minimum is known as vena contracta. Now the discharge measurement by orifice meter is given by the equation Q is equal to CD into A1 into A0 under root 2GA divided by under root of A1 square minus A0 square. Here CD is coefficient of discharge for orifice meter. CD is coefficient of discharge for orifice meter. A1 is cross-sectional area of pipe at section 1. A0 is area of orifice. So again I am telling you, this is orifice plate meter. This is the area of orifice. You can show. You can see in this figure that orifice diameter DO from here to here. So area is A0. This is the diameter of pipe having area A1 at section 1. This is U-tube differential manometer. The height of difference of mercury level is shown by H. So its formula comes out to be CD into A0 A1 under root 2GI divided by under root of A1 square minus A0 square. Next is PITOT tube. PITOT tube is a device that is used to measure the velocity of flow at any point in a pipe or channel. PITOT tube is a device used to determine the velocity of flow at any point in a pipe or channel. So this is our third device based on Bernoulli's theorem. This device is used to measure the velocity of flow. It works on the principle that if velocity of flow at any point becomes zero, the pressure there is increased due to the conversion of kinetic energy into pressure energy. You can see its construction and working. This is the figure of PITOT tube. You can see here that this one, a glass tube bent at 90 degrees. This is PITOT tube. So its construction and working is, it consists of a glass tube bent at right angle. The lower end of the tube called body is inserted into the stream of flow and faces the direction of flow, while the other end called stem is vertical and open to atmosphere. So basically PITOT tube is a glass tube. This is a glass tube bent at 90 degree. So the lower end called body is inserted into the stream of flow. This is the lower end. This one is the lower end. This is inserted into the stream of flow. Here, from here, the flow is coming. Flow. This is shown V. This is the velocity of flow. So this is the entry point. And faces the direction of flow, while the other end called stem is vertical and open to atmosphere. This part is vertical and it is open to atmosphere. It is called stem. This part is called body. This part is called stem. The liquid rises in the tube due to the conversion of kinetic energy into pressure energy. By measuring the rise of liquid in the tube, the velocity of flow can be determined. So we can see here in this figure that when this tube is inserted into the flow, this is called body, this part is called stem, this is open to atmosphere. When it faces the direction of flow, the liquid rises up in the tube. The liquid rises up in the tube, and by measuring its height from this free surface of liquid, we can find the velocity of flow by this formula. This is the formula for finding the velocity of flow. The actual velocity of flow by PITOT tube is given by the expression V actual, means actual velocity. It is given by CV under root 2GH. CV under root 2GH, where CV is coefficient of velocity or coefficient of PITOT tube. CV is coefficient of velocity or coefficient of PITOT tube. G is acceleration due to gravity, and H is height of liquid in the tube above the free surface of liquid.